I can use colored tiles in an algorithm to subtract integers. So here is an example of Dava's method to subtract integers. She worked on this problem here. Positive 10 minus 4, or minus negative 4, equals, and so what she did is she made it positive 10 plus the opposite of negative 4, which is 10 plus 4, which equals 14. If I was representing this with colored tiles or algebra blocks, I might represent the I'd put the positive 10 on the positive side of my map, and then I have to take away negative 4. Well, I don't have any negatives, so what I have to do is actually add in 0 pairs. So here's one negative, so I have to add in a positive, so I stay at 0, a negative and a positive, negative and a positive, negative and a positive. So now I have 4 0 pairs, but this allows me to take away negative 4 now, which leaves me with basically 10 plus 4, and that's what she ended up with, and that equals 14. So a couple examples. Probably won't go through all of these, but you can work on some of these practice problems on your own. So let's say this one, negative 4 minus positive 2. So if I were to set up counters on an algebra block mat, negative over here, positive over here, start with negative 4, 1, 2, 3, 4, and I subtract a positive 2. Well, I don't have any positives. There's nothing over here, right? So I have to add in positive 2. How do I do that? I add in 0 pairs. So this is 0 and this is 0. However, now I can take away positive 2. So I take these and get rid of them, and it leaves me with negative 4 and negative 2, which is negative 6. So using Dava's method, I would say this is negative 4 plus the opposite of positive 2, which is negative 2. Negative 4 plus negative 2 is equal to negative 6. You can generally say subtraction is, you're really adding the opposite. So for this one, we can try Dava's method first. Positive 5 plus the opposite of positive 9, which is negative 9. So now I'm just adding integers, which 5 plus negative 9. 9 has you have two different signs. 9 has the greater absolute value. So since the absolute value of 9 is greater, we know that the sum will be negative. And then we just actually find the difference. 9 minus 5 is 4, so the sum will be negative 4 in this case. Taking a look at these two examples right down here, you have, they want to determine the unknown integer in each number sentence. So you have positive 3 plus something equals positive 7. So what's the unknown integer in this? There's actually a wide variety of numbers you could say. I mean, you could go with as simple as, 3 plus 4 equals 7, right? I can't, off the top of my head, think of anything else that would go in here, but I know if you're dealing with more complicated things, you can sometimes come up with other ways to do this. 2 plus blank equals negative 7. So you're thinking, I have 2, and I gotta get to negative 7. So here are some counters. I have positive 2. I want to get to negative 7. So that means that ultimately I would need 0 pairs for both these 2's. 1, 2. And then I would need another negative 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be plus negative 9, and that would get me to negative 7. Now to go back through and use your fact families to figure this out, right? So you can obviously use fact families knowing that your sum minus an addend equals the other end. So you can do 7 minus 3, and that equals 4 to get that answer here, right? You can also do that over here, where it's a little bit more complicated because you're doing negative 7 minus 2. And so you'd say negative 7 plus the opposite of 2, which is negative 2, which then equals negative 9, because you're adding 2 with the same sign. So the sign stays the same, and you just add them. Negative 7 plus negative 2 is negative 9, which is the same number we determined using counters. And that is all I have for you today for I can use colored tiles and an algorithm to subtract integers.